Hey everyone, today I'm going to cover a derivative that goes over the quotient rule. The quotient rule is used when you have two differential functions. In this case, we have one on the top and one on the bottom, and you're dividing them by each other. So to start, we're going to first start by setting this equal to dy over dx. Okay, and that's going to set us up for our formula later. We're also going to separate this into two functions, the upper and lower function. So for the upper function, which is called u of x, and just remember, u is for upper. That keeps it the easiest. So u of x equals x cubed plus 5. And v of x equals x squared plus 3x. Now this is very important to keep it consistent as you go along. So our formula for the derivative of dy dx equals vu prime minus uv prime over v squared. So just remember you always have the upper sections in the middle of this formula, and then you have the v's on the outside, and remember u equals upper because it's the numerator of our fraction over here. So this is important to keep the upper and lower part consistent because you can see we're always dividing by our denominator in this function here in our formula. V is always going to be on the bottom, and we're always going to have vu prime minus uv prime on the top, and these are not interchangeable because we have the minus here in that middle section. So as you can see, we're going to need u prime and v prime for this equation to work. So let's start by finding u and v prime. So u prime is equal to 3x squared, and this is just a simple power rule, and v prime equals 2x plus 3. The x drops off here, and the 5 drops off there. Now let's plug these into our equation. And I'm going to rewrite this down here. Dy over dx equals vu prime minus uv prime over v squared. And when we plug in, we know that v equals x squared plus 3x, and u prime equals 3x squared. U prime, I wrote this wrong, so u is equal to x cubed plus 5, and v prime equals 2x plus 3. And we're going to put this over v squared. So once again, we have v u prime and u v prime over v squared once we plug that into our equation. I'm going to go ahead and distribute these. So we get 3x to the fourth plus 9x cubed minus 2x to the fourth plus 3x cubed plus 10x plus 15. And this is FOIL, if you remember that method, probably from your pre-calculus classes. And this is over x to the fourth plus 6x cubed plus 9x squared. And we can combine like terms in the top. So we have an x cubed and an x cubed, x to the fourth, x to the fourth. So when we distribute this out, we get x to the fourth plus 6x cubed minus 10x minus 15. And on the bottom here, we can actually factor out an x squared. So we'll get x squared times x squared plus 6x plus 9. And we can actually also further factor this down to x squared times x plus 3 squared. But we don't need to do that. The form above should be just fine. And this is our derivative using the quotient rule.